Thank you all for having me here to talk to you about the Common Statistical Production Architecture. My name is Thérèse Lalor. I'm an Australian, but I also working with UNECE as one of the project managers for the high-level group project. So every year the high-level group sponsors a small number of projects for things that they really want to accelerate and make sure that they are progressing well for the community. So the project that I manage is called the Common Statistical Production Architecture. And I've been involved with the project management of these HLG projects on many different topics. You could perhaps say I am quite general in my knowledge of statistics, from information management. Perhaps this is an architecture project, but also business process models. So hopefully you can give this sort of a high-level introduction to what the Common Statistical Production Architecture is about. Okay. The need to modernise is something that's been talked around many of the statistical offices, and certainly in the UNECE region for some time. We know that there is a situation that we need to address. There is this analogy about a frog in boiling water. You know, if you put the frog into the boiling water straight away, he knows that there's a big problem straight away. But actually, we are more like the frog who's been sitting in the water, slowly heating up. And now it's come to a point where we really realize that we're in a situation where we need to change our statistical organizations. And on the slide there, you can see there are a number of issues that make us know that we have to modernize. So things like aging technology. It's much more costly to collect data using more traditional methods that we have used in the past. There's all the time people asking statistical organizations to collect new types of information or more complicated problems which require us to collect social and business and environmental data and integrate them in some way. It's hard for statistical officers at the moment to really harness some of these great data sources that are becoming available to us now. But also, we are learning that in the age where data scientist is such an exciting career, we need the skills, the better skills, or different skills in our organizations than to perhaps what we needed. And these are skills that many other organizations want as well. So we are needing to think about our statistical organizations and how we can change to make sure that we remain relevant, but also that in sort of an age where we are getting less money from our government, we are able to perform efficiently. So the Common Statistical Production Architecture is trying to solve a problem. And talk a little bit about this problem. Perhaps in all your statistical organizations, you will have this situation where there are special processes and tools and pieces of software for each particular survey. So, you know, the labour force survey uses one process and one tool, but the health survey uses a different tool. And what you end up seeing in the statistical organization is when you look across all of it, there are lots of little different things happening everywhere, both in terms of the processes that are used and the IT system. This is hard for a statistical organization to manage efficiently when you're trying to manage so many different things that maybe are not different for a good reason. Maybe they could be standardized. So enterprise architecture is a way that helps an organization understand understand how to make this situation better. Enterprise architecture really grew out of the realization in companies across the world that they were spending more and more time and more money on building IT systems, and also realizing that these IT systems that were costing them more and more money were not really performing functions that were helpful to the business. They weren't helping the whole business. So enterprise architecture is a way that really helps you understand what is happening in your business right now, what is the situation now, and helps you to think about where do you want your business to be in the future, and then how do I get from this state that I'm in now to this new efficient state. So this is what enterprise architecture helps organizations do. And so really, by standardizing across the whole organization, you remove these silos that we've seen in the past, and it helps collaboration within your organization, right? So in a sense, this picture here shows how enterprise architecture helps you standardize. So every survey is using standard processes, standard IT systems. People are not being different just for the sake of being different. We've tried to really make it common across the organisation, which is great, right? Sounds good. Standardization is always a good move. But when statistical organisations work by themselves, perhaps there's no guarantee that we standardize in the same way. So you can see on this picture, Canada has these shapes of sort of, I don't know, zigzag edges, jagged edge, whereas Sweden has gone for a smooth, sleek, diagonal line. So they're both standardized, but in slightly different ways. But this makes it really hard for us to share and reuse across agencies. So you can see in the middle row here, Sweden perhaps is looking for some IT system to help them with dissemination, and they think, great, Canada's got a really good system, I'd like to use that. But because they're standardized in a different way, it's not so easy to just take the Canadian system and put it into their own environment because of this different idea of standardization. But if we work together, then actually we can make the same standard. We can all work to a common standard, common framework, and this is going to make it a lot easier for us to share and reuse software components. So now we're all building Lego bricks instead of our own special shape. Okay. So enterprise architecture is something that happens within one organisation. But CSPA is looking across the whole industry of statistical organisations. So it provides a template architecture, an industry architecture for official statistics as a whole. So it talks about what do we as an industry want to achieve, how we can achieve it, so some principles of how we build IT systems, and what do we need to do so that we can share. And this is sort of complying with some governance issues, processes that will make sure that what is being built is really the same and easy to share. So this is really great. They often call an enterprise architecture is a blueprint. It's a blueprint for how you can build things in your organisation. So the common statistical production architecture is, this architecture will help modernisation internally, and it's based on common standards. So these are standards that have already been developed by the community. It includes GSPPM, GSIM, DEI, SDMX. So what it's going to do is help us understand in our own organisations how we can make some standardisation and efficiency, but also how it makes it easier for us to take things from other organisations which we need or would like to use and put them into our own environment in a much simpler way. Enterprise architecture, everywhere, it's a standard across the world. Not just statistical offices using enterprise architecture, but businesses of all kinds. And this is a standard layers that are included in enterprise architecture. So you have a business architecture that tells you what processes does your organisation do, what activities do you undertake, and how do you do them. It has an information architecture, and this is helping you to understand the information that exists in your organisation. How does this information flow from one process to another? How is it used? How do you manage it? These are all questions that the information architecture helps you understand. And then application architecture is a set of practices which tell you how to design software. There is a small bar at the bottom you can see called technology architecture. This is not something that we really talk about in the common statistical production architecture because it's the infrastructure, it's servers and networks and very detailed IT technology type things. And this is something that's often not so easy to change. Each statistical organisation will have their own way of doing things, maybe set by their government or history, something like this. So we don't make any comment on that in the common statistical production architecture because this is something that's very individual for statistical organisations. So I said that common statistical production architecture, CSPA, is based on the standards that are already existing. So we have the business architecture, which I mentioned talks about what we do and how. Already existing is a framework for this in the community, which is called the Generic Statistical Business Process Model, which you can see on the screen. So it talks about all the different processes that are undertaken by a statistical organisation, from understanding what the needs are of your users, to understand what things you might collect in your survey, designing the survey, building the instruments, collecting the data, processing it, the analysis of the data, and then disseminating it at the end of the process with some evaluation. So this is something that's existing and is quite well accepted by most statistical organisations for an explanation of what we do. So this is what the business architecture is composed of in CSPA. The next layer was the information architecture. So this is another model that is already existing in the community and which we are taking advantage of. The GSIM, the Generic Statistical Information Model. This helps us standardise across the different statistical organisations how to talk about our information, so that when we say variable, we all have a clear definition we can understand of what a variable is. We can have a clear definition that's agreed what population is or what unit is. And with that, we can begin to understand. Information comes in and out of processes. So if you're running an editing process, for example, editing is an activity that's defined in the GS-BPM. You have some inputs, so maybe a data set, maybe some kind of rules that you're going to apply when you edit the data. These are the inputs to the process. Then you undertake the activity of editing, and then there is an output. So a new data set, maybe some metrics about what you changed in your data. GSIM describes those inputs and outputs to the process in a way that every organisation can understand because we have this reference model. So this is the information architecture, again something that's existing. What was not existing when we began the common statistical production architecture, agreed in statistical organisations anyhow, is the application architecture. So this is this agreed set of practices for how we will define and design our software. And this is the addition that CSPA makes. So it's based on something called service-oriented architecture. A service is just a representation of a real-world business activity. So editing could be you could have an editing service. You could have a classification service. You could have a seasonal adjustment service. So it's something that does one of the activities that we're talking about in the CSPA. And it just does just that one thing, but it's designed in a way that's generic, so that you can use this software to edit household data or business data. You could use the, I'm trying to think, record linking service may have a choice of methods. You could do probabilistic record linking or deterministic record linking. So it's the same service doing one thing that can be used for all the different surveys. So you can see on the slide it has standard input and output. So this means that you say, to do editing I need the data set. The data set is described in GSOM in this way. And we all understand that your data editing service takes these things in and has these outputs. This is important for connecting the system to your existing environment. And this is what makes these new software components really easily exchangeable between statistical offices, because we have a clear definition of what they do, a clear definition of the information that goes inside and outside them, and we have a number of other technical things where we all agree that to build in this certain way. If you're really interested in the technical things, there's lots of description in the CSPA document, but it's a very detailed IT information, so I'm not going to talk about it. So again here, you can imagine that a service is like this wooden block. You have the GSOM objects going in at the top, producing some kind of process, and having some output at the end. So this is sort of the new idea for statistical organizations. The idea that we should standardize on how we build our software components. So I talked a little about the different layers. So CSPA really is bringing together most of the already existing frameworks and models that are existing and bringing them together into one place for people to understand and apply to their statistical organization. So what does that really mean? What is the concrete thing? Well, actually, the CSPA has been going for 3 years. This is the 3rd year that we are having this project. But here last year, on the slide, you can see that there were quite a few services built. And they're built not always just by one country, but sometimes a number of countries collaborating to understand the requirements for it. You know, what would be the best use case? So on the slide there, I won't read them all out, but it gives you an idea of the kind of things people are building. Sort of sample selection, seasonal adjustment, error correction. At the moment, what happens is that statistical organizations are building these in alignment to the architecture. So they're describing the process according to GSPA. They're describing the information according to GSIM, and they're taking a note of the IT requirements for how they build it and how it interacts with their environment. And then today is the governance process where a group checks whether they have complied, and then these are available to use for any statistical organization. Okay. How do you know what's available? So there is a CSPA catalogue, and actually this is something that's been really built this year. There's lots of different layers inside the CSPA catalogue. The first one is knowledge base. And this is the place where you can go and find out information about all the frameworks that I've just mentioned, GSPPM, GSOM. You can read the documentation, find some presentations, discussion forum as well. The business plans and interest layer is something that we're building this year. And this is where we are asking statistical organisations to tell us, what software are you building this year? What things would you like to collaborate with other countries? So maybe people are very interested in web scraping or using semantic technologies to do the coding, for example. They can say, you know, in 1 year's time we'll have a project. And when we bring all this information together, it's really easy to see where there's possible collaboration opportunities between different organisations. If we can build the software in a way that 2 organisations straight away can use it after they've collaborated on the design. Business capability layer is where people can talk about what they already have in their organisation. You know, already we've got really great methods for editing, or we've got some really good information on how to train people in semantic technologies. This is where you can find out existing information rather than future plans. The statistical services layer is a catalogue. It's actually hosted by Eurostat. And this is where you can go and look and find out what pieces of software, statistical services, have been built that are compliant with the architecture and are available for you to use right now. Obviously, it's not huge at the moment. We just a few as we're beginning. But they're there. They're described in a number of ways, each with more and more detail, depending on whether you are a business user or you are the IT guy looking at how to actually deploy it into your own organisation. And then this last layer is a technical repository. It's where we store the code. So when you go to actually put it into your organisation, you have to go and get the code from somewhere. And that's this last layer. We're building many services this year as well. There's the validation rules, piece of software, classification, record linking, web dissemination. And also we're doing some work to test the services that have already been built. So one thing maybe you know in your organisations, when you bring a piece of software in, you need to really check that it's the right piece of software for your organisation. Does it match your processes? Does it match your methods? How will you use it in the production of statistics? The confidentialized analysis of microdata service is one like this at the moment. It uses a fairly new methodology perhaps. It's not used by many statistical organisations in their production systems. So we've got already 4 countries who have their methodologists looking at it and trying to understand how they will apply this method now into production. Sharing is not something new in statistical organisations. Already we participate in lots and lots of international engagement activities. We collaborate on the national accounts. We collaborate on how to use new data sources, all sorts of things. And all statistical organisations are looking to modernise and standardise their systems. So because CSPA is built on these frameworks that already most statistical organisations are aware of in some way, it's not a very high cost to align to CSPA when you are building software. But the savings that you can get from other organisations is really high because you don't have to invest the time and money into developing them yourself. Again, the confidentialized analysis of microdata services is a good example. It was developed by ABS. That was the Australian Bureau of Statistics. It was a big investment for them to understand how to make this work. But picked up by other countries already, they can jump 2 years ahead of where they were. They don't have to spend that 2 years beginning again to understand. So the sharing of software is just extending the sharing that we're already doing in our organisation. Already we have been talking to the heads of statistical organisations to sort of agree in principle that this is a good idea, that the sharing of software is something that will be beneficial to all of us. And the idea really is that statistical organisations contribute as much as they can, when they can. So perhaps you don't have to build the service, but you could find out that somebody's building a service for web dissemination and you're interested in that. You could maybe contribute by providing some requirements or some knowledge of how it works in your statistical organisation. And that country, when they've built it, will be able to share it with you. So you contribute what you can as you can, but the benefits are really quite high in terms of saving of IT costs. Okay, so some quick facts about CSPA. CSPA will help us to provide software components, statistical services built by the statistical industry using the standards. It gives us a really good framework for collaborating and sharing effectively. There's a full set of tools and templates and guidelines for your organisation in understanding how to implement CSPA to quite a technical level. It's something that will support the whole statistical process, so we will hopefully see software components being built for designing surveys all the way through to dissemination eventually as we build up our catalogue. But also it's a really good, vibrant international community actively supporting and implementing its framework. So there's a lot of people that you can talk to and get advice from as your organisation is starting to understand it. We have a public CSPA wiki, which you can go to and have a look and learn more about the different elements that I've talked about today.